Today's lesson is on perpendicular bisectors and angle bisectors. Okay, yesterday we went through the vocabulary to talk about these. So let's talk about the perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, so here's my segment AB. So if I have a point that lies on the segment, then it is equidistant from the endpoints of the segment. So it is going to say, so I am equidistant from the endpoints of the segment. Okay, so if line CP is perpendicular to segment AB and segment AP is congruent to segment BP, this is where we're going to say segment AC is congruent to BC. So the converse states, so the theorem is from P to Q, and the converse is Q to P. So if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So if I know that the distance from D to A equals the distance from D to B, then I know that line CD is perpendicular to segment AB. And that I know this is P is the midpoint. So A to P, or A to D, A to D is congruent to B to D. So I know, because I'm on the perpendicular bisector. Okay, so let's do some problems with this, with all these words. All right, find the measure of each. So I want to find R, the distance from R to S. So I know this is the perpendicular bisector because I'm perpendicular, and this is telling me I'm bisecting. So the distance from here to here is congruent from the distance from here to here. So if S to P is 6.8, I know S to R, or R to S, is 6.8. Let's find the distance from E to G. So it's asking me for this distance here. So since these two distances are congruent, I know this is the perpendicular bisector. So if this is 9.5, this is 9.5. So from E to G, it is going to be 9.5 plus 9.5. I guess it's distance, so there's no segment symbol. Just the distance from E to G, which is 19. Make sure you answer the question. All right, let's try C. So I know I have the perpendicular bisector because I'm perpendicular and I'm the midpoint, so that makes these two distances equal. So I can set up my equation. I'm trying to find the distance from A to D, so I need to know what x is. So I'm going to set up equation 3x plus 14 equals 5x. So I'm going to subtract 3x from both sides. I'm going to add the inverse. So I get 2x equals 14. I'm going to divide by the coefficient next to the variable. So 7 equals x. So I'm going to go substitute this in now. So 5 times 7 is 35. Okay, so that's for perpendicular bisector. Now let's work with the angle bisector. So the theorem is from P to Q, and the converse will be from Q to P. So the theorem says, if a point lies on the bisector of the angle, then it is equidistant from the sides of the angle. So if I know my angle is divided, then I know these two distances are congruent. So the theorem, so if ray AD bisects angle BAC and segment DB is perpendicular to ray AB and segment DC is perpendicular to ray AC, then segment BD is congruent to segment CD. Okay, so the converse starts with saying that the distances are equidistant. So if a point on the interior of an angle is equidistant from the sides of the angle, then it lies on the bisector of an angle. So if I know I am equidistant, then I know the angles are congruent. So then I know this is my angle bisector. So if segment DB is perpendicular to ray AB and segment DC is perpendicular to ray AC and the distance from D to B equals the distance from D to C, then I know that ray AD is the angle bisector. Okay. And my two angles are congruent. Okay, so let's do some examples. So find the measure of angle GFJ. So GFJ is this angle. So since these are perpendicular and equal amounts, I know that ray JF is the perpendicular bisector. So if this angle is 42 degrees, I know this angle is 42 degrees. All right, let's find the distance from R to S. So it's asking me to find this distance. I need to know what X is. So since I know my angle is bisected and I'm perpendicular here, that makes these two segments congruent. So I can set up an equation and solve for X. So 5X equals 6X minus 5. So I'm going to subtract 5X. I'm going to add the inverse, so I get 0 equals X minus 5. And I add the inverse again. So I'm going to add 5. So I get X equals 5. And now I can substitute. So 6 times 5 is 30, minus 5 is 25. Okay, this is a coordinate plane kind of question. Okay, segments with endpoints. This is an equation where I'm going to find the perpendicular bisector in slope-intercept form. So I have 2 points here. So just kind of taking a look here. I have point P is at -2, 3. So this would be point P. And point Q is at 4, 1. It's over here. So I am looking for the perpendicular bisector of this. So I am trying to find this perpendicular bisector of this line. So the first thing I want to do is find the midpoint here. So I'm going to start with finding the midpoint. So finding the midpoint, I'm going to add my two x values and divide by 2, and I'm going to add my two y values and divide by 2. So substituting in, I get my midpoint is -2 plus 4 divided by 2, and 3 plus 1 divided by 2. So -2 plus 4 is 2 divided by 2. So that's 1. And 3 plus 1 is 4 divided by 2 is 2. So my midpoint here is 1, 2. Okay, the next thing I want to do is find the slope of P to Q. So I'm going to find the slope is y2 minus y1. So 1 minus 3 divided by 4 minus -2. 4 minus -2. So minus a negative is a plus. So this is -2 over 6, which is -1/3. So I want the perpendicular slope, so that is my opposite reciprocal. So my perpendicular slope is going to be plus 3. So my next step is, now I'm going to use my midpoint and my slope and put that in point slope form. So substituting in, I get y. So this is x1 and y1. So y minus y1 is 2 equals my slope, which is 3 times x minus 1. So I'm going to distribute, so I get y minus 2 equals 3x minus 3. I'm going to add 2. And I get y equals 3x minus 1. So here's my equation in slope-intercept form. We are done.